Hey guys, this is Quideo for Unit 6. So the first question asks, the Census Bureau reports that households spend an average of 31% of their total spending on housing. A Builders Association in Cleveland believes that the average is lower in their area. They interviewed a sample of 40 households in Cleveland and in the metropolitan area to learn what percent of their spending goes towards housing. Take mu to be the mean percent of spending devoted to housing among all Cleveland households. We want to test the hypotheses. Ho is mean equals 31%, and the ha is the mean is less than 31%. The population standard deviation is sigma equals 9.6%. Question A asks, what is the sampling distribution of the mean percent x bar that the sample spends on housing if the null hypothesis is true? Sketch the density curve of the sampling distribution. Hint, sketch a normal curve first, then mark the axis using what you know about locating mu and sigma on a normal curve. So first, mu is the population mean and x bar is the sample mean. So I found the sample standard deviation first, and I found that to be 1.518%, and then I got n is 31%, and then 1.518%, and then I did the normal curve. The 31% is the mean, and then these are all the standard deviations. Yeah. And then B asks that the study finds x bar is 30.2% for the 40 households in sample. Mark this point on the axis in your sketch, and suppose that the study results x bar is 27.6%. Mark this on your sketch as well. Referring to the sketch, explain in simple language why one result is good evidence that the average Cleveland spending in the household is less than 31%, whereas the other result is not. So then I just mark them right here. And then I said the lower percent lies out on the low tail of the curve, whereas 30.2% is fairly close to the middle, assuming that ho is true. Seeing a value like 30.2% would be surprising, but 27.6% is unlikely, and thus provides evidence against ho. And these are also just my numbers, so n equals 40, sigma is 9.6%, sigma of x is 1.58%, x bar 1 is 30.2, x bar 2 is 27.6, the ho is the mean equals 31%, and the ha is, mu, 31%, ha, mu is less than 31%. And then C asks, sketch the area under the curve. That gives the p-value for the result, 30.2. And the p-value is just kind of like the probability of something happening in a test of significance. So this is where I shaded starting at the 30.2 area. And yeah, so I just kind of like where C is, I just put everything on this one density curve. So the advanced question is, Pew Research in November 2011 polled a random sample of 799 U.S. teens about internet use. 49% of those teens reported that they had misrepresented their age online to gain access to websites and online services. A asks, find the margin of error for this poll if we want 95% confidence in our estimate of percent of American teens who have misrepresented their age online. So this was my equation. So this was my equation. 1.96 is the z-score for 95% confident. And then 0.49, is the probability. And then 1 minus, and so then it would be 1 minus p, and then I just did 1 minus 0.49, and then over the sample size, which is 799, and then I got 0.035. And then over here I just wrote that z with this little like asterisk next to it equals 1.96, which is 95% confident. So that would be our margin of error is 0.035. Then part B asks, explain what the margin of error means in context. And then I wrote that we can be 95% confident that the true proportion of teens admitting to misrepresenting their age online lies between 0.49 minus E, which equals 0.49 minus 0.035, which equals 0.455, and then 0.49 plus E, which equals 0.49 plus 0.035, which equals 0.525. So it would lie between 0.455 and 0.525, which would be the true population mean. And then CS, if we are only 95% confident, will the margin of error be larger or smaller, and then explain. So I said the margin of error will be smaller. Being willing to accept a lower confidence level means we can pin down the mean proportion more clearly if E is smaller, the interval is narrower. And then the AP question says each person in a random sample of 1,026 adults in the United States was asked the following question. Based on what you know about the Social Security system today, what would you like Congress and the President to do during next year? The response choices and the percentages selecting them are shown below. Completely overhaul the system, make some major changes, make some minor adjustments, leave the system the way it is now in no opinion. The majority of people voted for make major changes. I mean, that's not really a question, but I mean, that's important to note because it does relate to the following questions. So question A asks, find a 95% confidence interval for the proportion of all United States adults who would respond, make some major changes to the question. Give an interpretation of the confidence interval and give an interpretation of the confidence level. So I wrote, there is a large sample confidence interval for the population proportion because n is greater than or equal to 200, so the n rise to the p power equals 1026 times 0.39, which equals 400.14, which is greater than 10n, and in parentheses 1 minus p, which equals 1026 times 0.61, which equals 625.86, which is greater than 10. And for the 95% confidence interval, it is 0.39 plus or minus 1.96, which again is 95% confident. And then the square root of 0.39 times 0.61 over 1026, which equals 0.39 plus or minus 0.0298, which equals the true mu is between 0.3602 and 0.4198. And then I did x equals 400, which would equal 0.36002 and 0.41971. We're 95% confident that the proportion of all U.S. adults who would respond makes some changes in between. Make some major changes. Sorry, I left out that word. In between 0.36 and 0.42. And then B asks, basically saying like somebody advocated for leaving the system, as it is now, commented, based on this poll, only 39% of adults in the sample responded that they would want some major changes made to the system, whereas 41% responded that they would only want some minor changes or no changes at all. Therefore, we should not change the system. And then we have to explain while the statement is technically correct, is misleading. So I wrote, this is a misleading statement, and it is because along with the 39% who wanted major changes, 19% also voted to completely overhaul the system. These two combined makes 58% of the sample. So in reality, more people wanted to make major changes. So yeah, that was it. Thanks for watching.